Hello, and welcome to Ipsa Dixit, a podcast on legal scholarship. I'm your host, Brian L. Fry, Spears Gilbert Associate Professor of Law at the University of Kentucky College of Law. My guest is Amanda Levendowski, Clinical Teaching Fellow with the Technology Law and Policy Clinic at NYU Law School. We will discuss her article, How Copyright Law Can Fix Artificial Intelligence's Implicit Bias Problem, which was published in the Washington Law Review. So welcome to the program, Amanda.
Thank you so much for having me. I'm so excited to be here.
Yeah, well, I'm glad to have you on. Your article's definitely gotten a lot of great attention from tech websites across the spectrum, and I'm really interested to have an opportunity to talk to you about it. So I was wondering if we could start by you helping listeners who may not be as familiar with some of these technologically related issues understand a little bit better what you mean by artificial intelligence. In other words, what kind of artificial intelligence are you talking about, and how does it work?
Such a good question, because I feel like, especially now, artificial intelligence has become kind of a catch-all for a bunch of different technologies. And in the paper, I talk about a couple different kinds of applications, but AI generally is just computer programs that are able to learn automatically through experience. And that can include natural language processing, which are applications of AI that basically work on how words are connected and work. So if you use a Siri or an Alexa or another voice-to-text assistant that's working on an AI system of computational linguistics or natural language processing. If you're doing it visually, that's usually some kind of image recognition that often relies on, maybe you've heard the term neural networks. That's more that kind of example of an application. But AI is more of a catch-all term for a bunch of different types of practical applications of technology. But the commonality is that they're systems that can learn automatically through experience.
And so how do they do that? How do you teach a machine to learn things?
It's such a challenging question. I am not an engineer by training. So to write this paper, I had to go read a textbook about how you actually do machine learning, which when most people talk about artificial intelligence colloquially, they're talking about a particular field called machine learning. And that includes both of the examples I gave earlier of most face recognition relies on machine learning. Most applications of computational linguistics rely on machine learning. And that's a field that blends mathematics, statistics, and computer science to basically create computer programs, like I said, to improve through experience automatically. And so the way that usually happens, at least with commercial AI now, is through feeding these machine learning algorithms a vast amount of training data. And the training data is basically meant to help the machine learning system develop a baseline of what those different data are, and to learn automatically how to use that data to actually do a task, which is the hard-coded goal, I guess, of the machine learning system. So to take like a really easy example, say you wanted to train an AI system or a machine learning system how to recognize a cat. Practically speaking, right, researchers could go through and just label the training data and say, this is a cat, this is a cat, this is not a cat. Or they could do what's called unsupervised learning, which is, uploading a bunch of training data, and rather than manually identifying sort of what the right image identification categorization would be, letting the AI system kind of doing that through abstraction to figure out what features are cat-like. And this has been done in a bunch of different ways, but one of the ones I find really interesting as an example of how that can go right and wrong is there was a machine learning algorithm that was trying to identify when there was a dog in a photo or a wolf in a photo. And it basically started using trees as a proxy because wolves were outside with trees and dogs were inside without trees. So the machine learning system never really identified what a dog was, but it did find a really clever workaround. And that's kind of the long and short of the concern with implicit bias as well, which is if you let a system go free, the human biases that have been ingrained or baked into, the code or the selection of the data set, or if it's supervised learning or categorizations, that piece of the labeling, all those human biases are there. And then there's still opportunities for these machine learning algorithms to behave in ways we don't totally expect, like identifying trees as proxies for dogs versus wolves.
Right. Okay, so maybe you could talk a little bit about how this kind of machine learning AI is actually used. Like, where might people expect to encounter it, whether they realize it or not?
Oof. Well, it's. I feel like at this point, it's almost better where you don't encounter it. Wow. Because if you're thinking about like machine learning at the most general, high-level applications, when you wake up in the morning, if you check your email or scan through Twitter, there's an algorithm showing you which tweets to prioritize. There's an algorithm that might be suggesting how to respond to particular emails, although if you've used that feature, you may recognize that it has varying degrees of success. If you use Google Maps and you use voice to ask Google where you would like to go, the actual mechanism that takes what you say out loud and translates that into text and then runs a search in the background and then pops up your map. There's machine learning algorithms at each step of that process. And it's also sort of what's behind your Westlaw searches, whether or not that's how we think about it, that's kind of what's happening. And I feel like we're at kind of a point where it touches at least one thing that most average Americans do every day, if not more.
Right. So if you need all of this data to make the automatic machine learning work at all, where does it come from? Like what kinds of data end up getting used?
Yeah. So part of it is that there's this implicit realization that copyrighted data can create challenges. And it's not necessarily how engineers think about it when they're approaching data. But if you look at the business models of some of the leading companies in AI right now, and in the paper I talk about Facebook and IBM specifically as examples, there's two kind of predominant modes of where corporations who are building commercial AI products might get training data for AI systems. And in the paper I talk about the build it model and the buy it model. And Facebook is kind of an example of the build it model, which would be you build a platform that, as a byproduct of its sort of main purpose, collects data that can be used for training data, right? So Facebook is a platform that is ostensibly, I don't know how you would describe it now. It's in everything. It could be anything. It's a rich tapestry. But originally was conceived as a social networking platform. But as a byproduct, people were constantly plugging in status updates and selfies, which could then be used for training natural language processing algorithms or training image recognition algorithms. So that's one example of the sort of build it model. You build a thing, and as a sort of byproduct of the thing, you collect data that can be used to train AI systems. Another possibility would be kind of the buy it system, which is relying on technological expertise and partnerships to generate training data to support those technological innovations. And I would say in the paper, I talk about IBM as an example of that, specifically with their Watson for Oncology technology, where they partnered with Memorial Sloan Kettering on a number of different types of training data from I believe doctor's notes, but also articles and other types of information that you would want for an AI system meant to help doctors working in oncology actually do their jobs. So that would be more of an example of the buy it model, where the AI creator is good at the tech and is looking for partners in specialized areas to provide the training data. But there's also possibilities that are problematic and biasing in different ways, right? Because it's tough to compete with a build it or a buy it if you're a small little startup. So you might be inclined to use something a little bit less high friction, some low friction data, and you might be inclined to say use public domain works of which we just got a bunch of new ones for the first time in quite a while this year. Or you might be inclined to use Wikipedia. The executive director of the Wikimedia Foundation, Catherine Mayer, said in a talk that the majority, like a significant number of the facts that are used in AI systems as training data come from Wikipedia, in part because they have favorable Creative Commons licenses that makes it possible to use articles as training data without the sort of copyright issues that might otherwise be dispositive.
Okay, so maybe I really like the distinction you make in the paper between high friction and low friction data. And I was wondering, maybe you could spend a little bit of time sort of breaking out what you mean by that. And when you use the term friction there, what does that mean? What kind of work is the term friction doing in your analysis?
Yeah, so the work that I think friction is doing in the analysis is just how hard is getting this data, because the easier the data are to get and manipulate and basically use to train an AI system, the more likely or more probable it is that an engineer or company is going to want to use that data. And so in the low friction context, you can think about this as sort of easily accessible and legally low risk would be the calculus. So if you're looking for data that are easily accessible and legally low risk, this brings us back to things like the public domain works or Wikipedia articles that are both easily accessible and, as a practical matter, considered legally low risk. On the high friction side, that includes, the build it and buy it models, right? Which is basically the high friction piece is how much would it cost to otherwise license the massive amounts of training data you would need to teach an AI system. And to go back to the sort of cat example, if you're trying to just create an AI system that can recognize cats, you would need probably hundreds of thousands, perhaps even millions of photographic images of cats to teach the AI system what a cat is, or to at least provide it with enough data to abstract out the heuristics of what features make a cat, right? Mm-hmm. But if you're thinking about how much that would cost to license, one image of a cat, I think I did this for Getty. I looked on Getty to see how much it would cost to license an image of a cat. And I think it was more than $300 for one image of a cat.
Oh, my Lord. Yeah, no, if you go through Getty, there wouldn't be enough money in the entire world to pay for licensing.
Right. It's like a different level of buy it model, right? And so if you think of it that way, if you were to go through, say, a Getty or other mainstream licensor to try to get enough images that you could acquire to train an AI system, you're talking about spending hundreds of thousands of dollars on training data alone. And that's not even counting what you'd pay your engineers or your marketing and sales teams or the folks who are overseeing this work. Which means sort of in terms of high friction, I guess friction and capital are actually almost synonymous here, as they are in many things. But you can think of it that way too, which is if it's easily accessible and legally low risk, it often happens to be cheap as well. And that's kind of the situation that we got into with the Enron emails.
Right. Yeah. So, and I can imagine like a lot of this data would be kept proprietary by the companies that are generating it in the first instance. And like really from a competitor's perspective, it would be sort of nuts to license the data to someone who's trying to train a system to compete with your own, it seems like. And so, yeah, I was wondering if you could spend a minute talking about that particular collection of emails, which amusingly enough has become, it sounds like a go-to source of data for machine learning training.
Yeah, they totally have. And part of the reason is the Enron emails are both freely available online in machine readable formats. And as a practical matter, the likelihood of some of those former Enron employees suing for copyright infringement is pretty low. So to back up for a second, the Enron emails are, I think, 1.6 million real emails that were sent between Enron employees that were then publicly uploaded by the Federal Energy Regulatory Commission, or FERC, I think in 2003. And these emails are really interesting because they're one of the only large sets of emails that were exchanged between real people until, I guess, 2016. And the Enron emails are sometimes colloquially referred to as being in the public domain. But that's not quite what happened. I think that they're more like orphan works as a copyright matter. But the effect is the same result, which is basically the Enron emails, as far as people who create training data sets are concerned, are pretty low friction. And they can actually be really good for training some kinds of AI systems that are meant to deal with emails, things like spam filters or like foldering systems. But they've become very popular, and there is some estimations that a number of the sort of AI systems we take for granted rely on Enron emails as part of their training data set. But the concern I always have with the pervasiveness of the Enron emails is we should think maybe a little bit more about why we have these emails in the first place. Because if you think there might be significant biases embedded in emails sent between employees of Texas oil and gas companies that collapse under federal investigation for fraud stemming from the company's systemic, institutionalized, unethical culture, you'd probably be right, because the Enron emails aren't representative. They're not geographically representative. They're not socioeconomically representative. Sort of as matters of race and gender, they're not representative. And researchers have actually used the Enron emails to show and analyze issues of gender bias and power dynamics. But even though we know what these biases are, they still are a popular data set for training AI systems because they are low friction for the reasons we talked about earlier.
Right. Only the best biases, I'm sure, right?
Only the best, only top-notch artisanal biases.
Right. So in your paper, you point out something I think really interesting and important, which is the way in which copyright creates a huge amount of friction in the way you're describing it, both in the sense that, as you mentioned earlier, there's, copyright goes with licensing, and that means money and capital is friction, but also the legal risk associated with copyright and the uncertainty about the potential for, what could be a really crippling lawsuit. So what kind of incentives does that create for people who want to use machine learning to train an AI system?
Yeah, I think right now we are seeing the results of how this can constrict competition. Because if you are a company that manages to find a creative way to be a new build it, chances are high that you're going to get acquired before you actually rise to the level of meaningful competition with some of the dominant AI creators. There's only really, I think, about 7 companies that are considered to be dominant AI creators. And part of the reason is because if you get to a certain point of either accuracy, so there's competitions where you can sort of set your AI systems to battle and see how accurate they are at, say, like an ImageNet competition. If that's the case and you perform very well, you're going to attract the attention of these bigger companies. And a lot of the cases, they are going to try to acquire these smaller startup companies. So even if you can compete on your own build it model, it may be that you only can build so high, if that makes sense.
Yeah. So, I mean, if companies are either getting bought up or finding it hard to find data sets that they can use because of potential copyright concerns, where are they going, and what kind of biases are those creating? I mean, what's the problem, as it were, with other public domain sets of data? I mean, it seems pretty clear that the Enron emails have some pretty serious issues, but aren't there other public domain data sets that companies could use?
Yeah, and one of those would include like actual public domain works. So, to go back to what the appeal of the Enron emails, part of it is that it's available online in machine readable formats, which makes it easily accessible and legally low risk. And so literal public domain works assembled into a data set kind of hits those same beats, if you will. So things like Project Gutenberg or the Internet Archive, they allow pretty much anyone with an internet connection to access a bunch of machine-readable versions of public domain texts. So these kinds of digitized public domain works can be usable for certain applications of AI systems like natural language processing or computational linguistics. The problem is that words change meanings, and how we use those words change meanings. And The example I give in the paper of what it would mean if we only trained an AI system using exclusively public domain works basically means that for the most part, you're relying on works that were published before 1923 in the United States. And any data set that's predominantly comprised of pre-1923 works is going to reflect the biases of that time. So take the word queer, for example. That has a very different meaning from when it was kind of transitioned in its meaning in the 1800s because the Marquis of Queensberry transitioned the word when he used it to describe basically poet Oscar Wilde when he found out his kid was having an affair with Oscar Wilde. And that definition from the 1800s is very different from another definition more recently, which would be recreating it as a term of empowerment by the LGBTQ community or in some people in it. And if you were to try to use an AI system that were to identify when, say, a teen asks a voice recognition system whether she might be queer, something trained on pre-1923 works is going to have a pretty different understanding of what that person is asking than something that might have than a training data set that has access to more recent works that reflect the more contemporary meaning of the word queer.
Right. So maybe, what kind of negative social effects seem to be associated with these sorts of implicit biases kind of getting worked into artificial intelligence, machine learning systems by virtue of the sort of assumptions embedded in the learning materials?
Yeah, if we are sort of doomed to only rely on works that we know are biased in certain ways, our AI systems are going to be predictably biased along those same lines. And the one thing I joke about is that for all of the different snafus we've seen with sort of like AI mislabeling images, sometimes humorously, sometimes devastatingly, I think that part of the question there is going to be, do we want to have AI systems where the only real thing that they're consistently good at is telling us that people are biased? Or do we want to actually think about what we would need as training data to create more accurate and less biased AI? And that's all saying with that in mind of, one of the big applications is not face just detection, which is what I would describe as just recognizing that there's a face in a photo, but face recognition. And real-time face recognition, I think, poses some really different privacy questions and dignity questions that are a little bit different than other applications of AI and training data.
Yeah. So far, it's sounded like copyright is mostly just generating friction or problems. But in your paper, you suggest some ways, or one way in particular, that that copyright doctrine might also reduce some of that friction. So I was wondering if you could spend a little bit of time talking about what that is, how you think it might work, and what kinds of beneficial effects it might have on the generation or the creation of machine learning algorithms.
Yeah, one way to think about it is that while copyright law has this kind of profound and terrifying power to bias our AI systems in a way that we don't totally think about in that context, it also has this really amazing power to potentially unbias them. In the paper, I focus on fair use as one way to do that, but there are a couple others that I certainly am interested in. A court could definitely find that this is de minimis. We don't have enough it's hard to imagine what the case would look like, but because these machine learning or these AI systems vary so much in how the training data are collected and how the algorithms actually rely or abstract different heuristics out of those images, it could be possible that the law should not concern itself with these kinds of copies. Or to paraphrase Judge Laval, this is sort of like photocopying a New Yorker cartoon to put on your fridge that belongs to a category of copyright questions that never need be answered. So that's one possibility. But we don't have a great sense of how a court is going to deal with this, which is why I think that fair use is a likely possibility, which is a court could find that while, yes, a number of copies of these images are made in order to use them as training data, It's actually a fair use of all of those images. And under the Copyright Act, a fair use of a copyrighted work is not an infringement of copyright, which would wrap up some of those issues and put what would be perceived maybe as high friction data back into the low friction category, because it would go back to being easily accessible and, as a fair use matter, then legally low risk.
Yeah. So in your paper, you kind of acknowledge that there is a certain amount of uncertainty associated with fair use, but you point to some analogies to recently decided cases that suggest maybe an angle that that potential litigants in a fair use dispute over AI training data might use. I was wondering if you could point to some of those and why you think they might be helpful as a way of kind of analogizing between those cases and the circumstances you're describing.
Yeah, I think that the closest, most recent examples of when you can use a bunch of copyrighted works for a commercial purpose, but it also has a really strong public good aspect to it, would be something like the Google Books case that came out of the Second Circuit. Because even though Google Books is relied upon by researchers and scholars and nonprofit organizations, it's called Google Books. It's owned by Google and created by Google, right? There's a profit piece to it, or there could have been. And there's or I don't want to say profit piece, but there could be an interpretation of a commercial piece to it. And there the court found that despite the fact that it was run by Google, that Google Books was a fair use of the works that Google had been digitizing meticulously over time, in part because there was a real public good that came out of these works being accessible in a different form and in a different way. And while transformative is not part of the transformativeness is not part of the codified 4-factor test under the Copyright Act, transformativeness is still very relevant to the analysis, especially in the Second Circuit. And in the Google Books case, the court found that this was a transformative use. And on that piece, I think that that's really informative for what might happen with AI training data, which may not be transformative in the way people usually think about it, but may still be transformative in the eyes of a court.
So like transformative in the sort of ultimate end outcome, as opposed to transformative in the sense of how the work itself is actually used or changed.
That's such a good way to say it. And Professor Matthew Sag has kind of talked about this in the context of what it would be like to use copyrighted works as, quote, grist for the mill, as he calls it, and whether that would be, using copyrighted works as grist for the mill would serve a fundamentally different purpose than one that values works for their original authorial expression. He's referred to these kinds of uses as non-expressive uses. But I think it's very closely related to what you were saying, is sort of focus on, is the output doing something different? Not output in like a AI algorithmic sense, but in an actual, what is the result? What are we actually looking at here sense?
Yeah. Well, so Amanda, if courts were to take this kind of fair use perspective on the use of data sets for the purpose of machine learning that you're suggesting, which sounds frankly pretty plausible to me, and I thought your analogies were quite compelling. What kind of additional data sets do you think that would potentially open up to people who want to train machine learning systems, and why would they be better than the training set data that they have now?
Well, part of my hope would be that it could be more transparent. So one of the challenges right now is that we don't always have a great sense of what the training data are for particular commercial AI systems. And my theory is that part of the reason that it's going to be tough to get more transparency on that front until we have more clarity around whether using copyrighted works as training data for AI systems will constitute a fair use, or court would find such a thing, is that companies are not going to want to open up their training data sets if they are facing up to $150,000 of statutory damages per infringing work. It's like, when we were going back to the licensing question earlier, it was going to be cost prohibitive to license an image for, $300 or enough images to actually train in a system. When we're talking about the millions of pieces of copy or the millions of copyrighted works that would be transformed into training data with that kind of statutory damage attached, I understand why companies would not necessarily want to open up their training data sets to scrutiny. But my hope would be that we could have, one, more transparency if companies had some assurances that this was not going to not just destroy the particular product, but probably destroy their business in some instances, depending on how bad the judgment was. And two, potentially more opportunities for collaboration. Right now, the competition component that we were describing earlier, which is when you get good enough, you get bought up before you can really compete. If there's more openness and transparency around data sets, that could actually improve not just one company's AI system, but multiple companies, because they could see sort of where their gaps are and see what other companies might be doing to improve or tweak along the margins to fix those problems, and they could learn from each other, which is something that doesn't happen, I think, nearly enough in this space right now.
Does the lack of transparency that we currently see as a function of the sort of uncertainty around copyright create any problems specific to implicit bias as well?
It can, but I think part of the implicit bias question there is that people get attracted to bias, low friction data that are also sort of challenging or problematic as a matter of privacy. Because when you have these sort of like ephemeral legal questions, which people may not be thinking about in that context, they might get attracted to, hacked data sets or, quote, public data sets that are not really public in the way that people expect them to be used. And the examples I use of these in the paper would be the Hillary Clinton emails that were hacked and then leaked are available now online in machine readable formats. They're easily available, and they're already being used to train AI systems about how to basically filter your email, is one application that's being used by a company called Zero App, I think.
Wow.
And so that to me is sort of, there's an attraction to use those emails, even though as an ethical matter, we might want to think a little bit more deeply about whether we want to be, as a matter of course, using hacked content as training data for our AI systems, even if it's something as what seems as simple as just categorizing email.
Yeah.
Yeah. And the same thing happens when people scrape their own data sets. Sometimes you can think about scraping as an automated way of copying. And there may be instances where, for your particular AI application, it would be impossible for a person to collect that number of, copyrighted works to use as training data. But in some contexts, the things that you scrape can be, again, kind of fraught as an ethical matter. There were a number of researchers over the last couple of years who've either gotten images from online dating sites or YouTube videos of people who are undergoing a transition and use those to train AI systems in different applications. And I think one of the questions we're going to want to think more about, and which I hope courts will be really considered as they look at these questions as they're presented as a copyright matter, is do we want to be encouraging implicitly people to rely on ethically dicey data because the copyright questions seem so insurmountable for researchers or small startups? I think the answer is we should not be encouraging that, but that's kind of the implicit, it's like a meta implicit bias, the implicit bias of how copyright law works or how it's perceived by people and its intensity and power may be driving them implicitly to rely on garbage data, whether that's data that we know have biases or whether it's building your own data sets that seem easy and legally fine, but have some other ethical questions that are trickier than what we're currently seeing the discourse address.
Wow. Well, Amanda, thanks so much. It's really been a pleasure talking to you about your fascinating paper. And I guess we'll see going forward whether the industry and the courts start to adopt some of your suggestions.
Yeah, we'll see. I'm very curious to see. We have not had the first sort of case about this issue yet, although there is a pending case called High Q that touches on some of these issues, but not all of them.
We're here with with Alan Arkin, who's one of the stars of the new comedy Fire Sale. Was it difficult getting into your role?
That sounds dirty to me. You don't get into a role. You do it.
What is the title of the movie again?
Fire Sale. Come and see it if you have half a chance.
It's unusual for a major Hollywood actor and director to beg like that. Are you embarrassed?
No, I have a large percentage of the profits.
Fire Sale. It's just plain nuts. Rated PG, parental guidance suggested.